In an earlier lecture video, I told you how that I think we do word problems kind of in a strange way. Later, we're going to know how to work with x and y variables in the same word problem. So we'll have two I don't knows. And that is a much, much easier way to do word problems. Here we're going to do exactly what I was warning you about. So these are the difficult word problems, which would be much easier with some later skills that we have in algebra. But let's get started. I tried to break this, I think, into a couple different sections if I remember right. The first thing we're going to need to just remember is that if I have an amount of money, so say I have $1 and I have quarters, so obviously each coin I must have 4 coins. So the value of that particular coin has to be multiplied by how many you have to get the total amount of money, right? So we're going to need that in order to build these word problems here. So you definitely, I just told you how it's easier with two I don't knows, and I'm jumping ahead there. So I'm going to make my dictionary. We absolutely need our dictionary for these. I'm going to have dimes and I'm going to have nickels. Now, we've seen this before, that one of them can be built from the other. We can't have two I don't knows at this point. So now let's look at this sentence here. 9 more nickels than dimes. Do you see that we could build the nickels off the information we have about dimes? So if I make dimes the I don't know, I can build what I need to know about nickels. I have 9 more nickels than I have dimes. Now, I absolutely think the dictionary is essential for these here, so please make this. If I were grading you in class, I'd give you a point just for having the right dictionary if you got nothing else right in the problem. Okay, now we're ready to start building this. We know that we have $2.25 in our pocket, or whoever this is does. Now, you're like, there's no other information. Well, we know the nickel or dimes. We know we have some nickels. This is the number of coins. Well, if you multiply the number of coins by their value, you have the total amount of money. Now look what I've done here. Nickels is in parentheses because this is all nickels. Everything from the dictionary says it's all nickels, x plus 9. So I've put that in parentheses. And the reason is now we have some multiplication that has to be done. We have to do the distributive property. If we just multiplied the x by 0.05, we'd be incorrect. That's not the whole number being multiplied, so I need the parentheses. Now here's where we can go with this. What would that be with, I guess, 0.45, right? All right, now it's decimals. Now we've learned a trick to clear out the decimals. If I were working with fractions, I would probably do it. But since this is money, I don't think it's necessary. This is pretty easy. And I would also, if there was any question with the decimals, I'd just use my calculator. But I have to still do the same steps I would have done before, which is I got to clean this room up. I have some x's that can be combined, so I've put them together. 10 cents, 15 cents, so I've got 0.15 x's. This is the same thing. Just add that up on your calculator if you don't see it. Now, we want to get the factor puzzle alone. We want this guy, so we're going to get rid of this guy. Get rid of the 40.45. So I don't want to mess this up. I'm trying to do some 1.8. Okay, now we're just going to divide both sides by 0.15. It's a decimal, but it doesn't change that fact. Something's in front of x, we just divide it away. So I'm going to divide that 1.8, and I get x is 12. Okay, now you're not done. They want each type of coin, so we've got to go back up to our dictionary. Dimes is x, so we know that's 12. Now remember how we did this? We need this to find nickels. It's 12 plus 9. There are 21 nickels. 12 dimes, 21 nickels. Okay, watch me do this again. Let's go through it again. So what do we have this time? I'm going to build my dictionary. I've got dimes and I've got nickels. One of them can be built off the other. She has 7 more dimes than nickels. So do you see this time we're going to make nickels I don't know. We can build the dimes off the information for the nickels. She has 7 more dimes than nickels. Okay, now I'm ready to go here. Now I've got a total of $2.05 in all of my money, but I need the total value. So I'm writing nickels and dimes, and notice again I'm putting this in parentheses. That's all a number. I can't just do x plus 7. It's got to be in parentheses. Now I'm going to multiply by the amount, so that was the dimes. This is my nickels. This is how much they're worth. Now I have to distribute this. So I sent that here. I sent that there. Okay, now same steps as always. We got to clean up our rooms. This is going to come together to make 0.15x. Use your calculator if you need to. That's a 0.7. Okay, now we want the factor puzzle, so I'm getting rid of the 0.7. Now, just like I always would, and I get x is 9. Okay, now that was the nickels this time. So that was 9. The dimes, I need my dictionary, 9 plus 7. So 16 dimes and 9 nickels. Alright, I'd really recommend you pause the video and give this a shot. But I will start. I've got nickels and quarters this time. So one of them is going to build off the other. 12 more nickels than quarters. So quarters is my I don't know. I've got 12 more nickels. Okay, there's $2.10 in the pocket, whatever this is, or backpack. So I've got quarters and I've got nickels, but I have to put that in parentheses. Okay, so we need the value of each. A quarter is worth 25 cents. A nickel is worth 5. I'm distributing this. Double check myself here so I don't screw up. Okay, so now, it's just like always, there's decimals in it. It doesn't change anything. We have to combine like terms. Okay, so I've combined them. Now I want the factor puzzle by himself, so I'm going to subtract this number. It's a decimal, but that doesn't change the root part of the algebra. It's the same. Now divide both sides by 0.3. Again, you could clear the decimals. We learned how to do that. You could clear all the decimals out if you want, but if you use your calculator, which is perfectly fine with me, then it's not really necessary. So we get 5. Okay, now we found the quarters is 5. So here's my dictionary. Quarters is 5. Nickels is 5 plus 12. I'm just plugging that in for, if we know x now is 5, so plug it back in. I get 17. Okay, so this is the same. All that's going to change here is they've made it more complicated to set it up. So now more than ever we need our dictionary. So one of these is going to be I don't know. We can build the other one from that. Twice as many pennies as quarters. So I'm going to make quarters my I don't know. And then I have twice as many. Twice as many pennies as quarters. That would be 2x. Okay, because the quarters was I don't know, we have twice as many, so we're multiplying it by 2. So now we're still doing the same thing. We have these coins in our pocket. They add up to be $2.43, but we need their value. So this was my quarters, and then here's my pennies. So now, technically, so we're not going to have to distribute this time, but I did need to show that this is multiplication here. So that's why I put the parenthesis. So you're never wrong to put the parenthesis, especially on the more complicated ones, so that you know what you're doing. Okay, so I got 2 times 0.01. Okay, since we didn't distribute, all we have to do is combine our like terms here. We get 0.27x. So the room is now clean. We're just going to divide both sides by 0.27. We get x is 9. Okay, now that was the number of quarters. So we know the pennies is 2 times 9, so it's 18. Okay, let's try it again. Let's see, we have nickels this time, and we have dimes. We can build one from the other. She has twice as many nickels as she has the dimes. So we're going to make dimes, I don't know. This is twice as many nickels as dimes. Well, if dimes is I don't know, and we have twice as many, we've got 2x. So I'm going to go ahead. Are you getting comfortable enough that I can do this? So same thing, I just did it in one shot. Got my numbers of each of those coins. There's their values. So I'm just multiplying those. Combine like terms. I get 0.2x. Okay, x turns out to be 21. So if this is 2 times 21, we must have had 42 nickels. Okay, as always, I recommend you pause it, but it's up to you. Okay, building my dictionary. We can build one from the other. She has 3 times as many dimes as quarters. Okay, I hope I didn't go too fast there. You can build it off the quarters, and she has 3 times as many dimes. So a dime is worth 10 cents. Now I wrote that the other way than I have been doing it, so let me change that. That's how I've been doing it. Do you agree with that? Okay, so multiply that through, I get this. Now combine like terms. Decimals doesn't need to scare you, it's just numbers. Now I have a number in front of x, it's the same principle, just divide it away from both sides. So x turns out to be 17. So dimes is going to be 3 times 17, which is 51. So I have 51 dimes, 17 quarters. All right, it's the same here. They're just getting really complicated. There's my pennies, and then I've got nickels this time. Okay, one can be made from the other. Nickels is 2 more than 10 times the number of pennies. Okay, as confusing as that is, it just means so far that nickels is or pennies rather is I don't know. Now let's build nickels off of pennies. 2 more than, we're going one step at a time, translating from English to math language. 10 times the pennies. You okay with that? 2 more than 10 times the pennies. Okay, so now that we have the more difficult one set up, it stays the same. It's a penny is worth 0.01, and we have nickels is 0.05. Now, just because in algebra we normally write this the other way with the x leading, I'm going to flip this around, but it's the same thing, and that's $2.14. Okay, so I've got 0.05 times 10, 0.5x. Oops, hold on, that's not supposed to be, sorry. So he's going there, and he's going there. Okay, we got to combine our like terms. Now factor puzzle is last, so we're getting rid of that 0.1. Dividing both sides by 0.51. I don't know why I'm doing this in my calculator because I already know what's going to happen, but just to make sure I don't screw it up. Okay, so x is 4, so there were 4 pennies. Now nickels is 2 more than 10 times the number of pennies. So I'm just putting 4 in there for x. I get 40, 42. I had 42 nickels. Okay, let's do a few of these harder ones. I think there's still one more topic, I think. I've got nickels and quarters. So here's my build sentence. The number of nickels is 5 more than 2 times the number of quarters. So I can build nickels from the information of quarters. So quarters is going to be my I don't know. Now we'll go one step at a time. Nickels is 5 more than twice the number of quarters. And quarters is I don't know. So a nickel is worth 5 cents. Again, I'm flipping this around because that's usually what we do in algebra, but with the x in front, and that's $6.55. Now we're distributing here. I don't do decimals very much, so I think I know what it should be, but I don't want to screw it up. Okay. Now let's combine like terms here. So I've got 0.35x. So I've combined my like terms. I got x's here and x's there. I'm putting them together. Now let's subtract away that quarter because I want the factor puzzle to be last. Now I divide both sides by 0.35. It's just a number. It doesn't mean anything different. So the same rules apply. I get x is 18. Okay, I've got the quarters. Now let's do the nickels. I'm going to do it down here because there's not a lot of space. 5 more than twice the number of quarters. So that's going to give me 5 plus 36, which is 41. So I had 18 quarters and I had 41 nickels. Okay, I really recommend you pause this one here because I think we're about to move on to another topic. I'm going to start it. Oh, okay, we can build one from the other. The number of dimes is 7 less than the total number of nickels. So nickels is the one I can build off of. 7 less than 3 times the number of nickels. So this reads 7 less than 3 times the number of nickels. But remember, less than makes us go the other way around. So this is actually what it's saying. 7 less than 3x is actually this, 3x minus 7. Okay, so let's build it. Don't forget your parentheses for all of this. Dimes is that whole thing. So you need a parenthesis. And there's $7 in the jar. Okay, we're going to distribute this. I'm sending that there and there. Okay, combine my like terms. Putting my x's together. Okay, got to add 0.7 to both sides because I want the factor puzzle to be last. Okay, divide both sides by 0.35. And I get x is 22. Okay, that was the nickels. Now we've got the complicated dime thing, so I'm going to put it down here. Subbing in for the x. I know x is now 22. I've got 66 minus 7, or 59. So 22 nickels, 59 dimes. Okay. So, same thing. These are much easier later. but we're going to do student tickets and adult tickets. But we're going to do the same principles that we've been doing here. Um, well, let's just build the dictionary and I'll take you from there. Uh, the number of adult tickets sold was 5 less than 3 times the number of students. So if I say students is I don't know, I can build the adult tickets off of that. It's 5 less than 3 times the number of student tickets. But remember, less than makes you spin it around. So it's actually this. Okay, there's my dictionary. Now, we're doing the same idea we did with the money. I've got, here's the number of student tickets. I'm putting all of this in parentheses to be the adult tickets. Now, if I multiply the $6 per ticket times the number of students, that's the money that I've made off students. And if I do the $9 times the number of adult tickets I sold, that's the money that I made off the adults. So this is the total money off students. This is the total money off adults. You put it together and you get 1506. Is the total amount of money the school made. Does that make sense? So just like we did with the money, we said how many did we have and how much were they worth? Well, we're multiplying, this is how many they had. We're multiplying it by how much they're worth, the 9 or the 6. Now, I'm distributing. Combining like terms. So I cleaned up the room on the left. Now, we're going to get the factor puzzle alone, so he's leaving first. Okay, divide both sides by 33. So x turns out to be 47. So back to the dictionary. They sold 47 student tickets. So how many adult tickets must it have been? I'm putting that back in for x. And I crunched all this, got 136. So they sold 47 student tickets and 136 adult. All right, same concept here again. What do we have? Is it students and adults? So we have 1 day passes and we have tournament passes, but it's going to be the same idea. So one of them can be built off the other. So let's see. Tournament passes was 37 more than the other. So tournament passes can be built off 1 day passes. And how do we build it? It was 37 more than the 1 day passes. Okay. This is the number of each of the passes that were sold, but how much are they worth? The 1 day passes are 20. The tournament passes are 30. If you add that, now it's a total amount of money because you multiplied it by the value of each one. So now that's a total number of 1 day passes. That's how much money from each of those. It adds up to 17,610. Okay, distributing. Okay, combining like terms, the x's go together. So I get 50x so I've got 16,500. Divide both sides by 50. So I have 330 1 day passes, and I know the tournament passes are 37 more than that. So there must have been 367. Okay, totally recommend you pause it here, but we're back to adult That's kind of silly. Okay, we've got adult and then senior or child tickets. Now, we can build one. Yeah, so we can build this special tickets off the number of adult. Do you see that? It's 25 less than, so it's all being billed off adult tickets. So now we've got 25 less than twice the number of adult. But less than makes you flip it around. So you get this dictionary right here. Okay, so adult tickets were $10 per ticket. This is how many tickets. So that's the money off the adults. All of this in parentheses. All of this at $7.50 a ticket is the amount of money off the seniors and the kids. And they made some pretty good cash. That's a 0. Okay, so we're going to distribute here, send him through. What would that be? So don't forget the negative sign there. So he went there, we get negative 187.50. Okay, combine our like terms. We've got 25 x's now. We're going to add that to both sides. Okay, I've got 25x is 261250. Now divide both sides by 25. And something has gone wrong. Let me double check here. So $10 each. 25 less than twice the number of adult tickets. Yeah, I don't see what I've done wrong, but I got a decimal, which is impossible here. So I'm assuming they've made a mistake. That does happen sometimes. I don't see mine. Perhaps I did, but this is the concept here. Let me move forward because I don't. Double check it one last time. 25. Yeah, that's not going to work. I don't know what they did. Or perhaps it was me. I don't know, but I don't see it. Okay, so I got a decimal number of tickets, which can't be. So I'm going to roll forward. Just assume they messed up. Okay, same thing here. I've got. Oh, I know what they're going to do with this one. I got kids tickets and adult tickets. Now, yeah. What's different here is that they told us the total number of tickets sold, and that's all they told us. And so we're going to have to do a pretty clever little trick here. You could pick either one of these to be the I don't know. I'm going to make this the kids tickets as I don't know. Now, you're like, well, what are we going to do to build the other one? Because we have to build it. Well, if I know the total number of tickets sold, couldn't I do this? If there were 800 tickets sold in total and X of them are the kids' tickets, doesn't 810 minus X have to be the adult tickets? Does that make sense? So I've got kids' tickets and adult tickets. Well, there's 800 tickets sold. So 810 minus X must be the number of adult tickets sold. So pretty tricky. I hope that makes sense to you. So there'll be more of them. I'll talk about another one here. But so now after this point, it becomes the same thing we've done so far. Kids tickets are 3 each. Adult tickets are 5 each. And we made $2,820. Okay, so now don't forget we're distributing that 5. I get 4050 minus 5x. So the 5 just went to both of those. Now combining like terms, oh, thought this wasn't going to work out either, but I think it will. So combining my like terms, you had $3, but you owe me 5. You have minus 2x. Now this is what made me think this is odd. But what's going to happen is I'm going to get the factor puzzle alone by getting rid of 4050. And we're actually going to have negatives on both sides, which is what was scaring me. So now this doesn't look like it's going to make any sense, but when we divide both sides by -2, it's going to work out. We get x is 615. So 615 kids tickets were sold. Adult tickets are 810 minus that 615. And so we get 195 adult tickets. Okay, hold on, I'm just seeing, wow, this is a lot. Okay, so we got a bunch of these, so let's keep rolling here. So I've got adult and I've got student. All right, so once again, they haven't told us how this breaks down, so we can do this either way. I'm going to say adults is I don't know. Now, if she had a total of 115 tickets, that must mean we could build student off of this by taking the total number. Doesn't that have to be the remainder amount of tickets sold? If adults is X and there were 115 sold, the remainder, those that are left over, has to be the kids. Okay, so it's 12 times X for adults, 5 times 115 minus X for kids. Remember parentheses, and then the total amount sold. So we're distributing this. I get 575 minus 5x. Okay, combine like terms. You got 12, take away 5, got 7x. We want the factor puzzle alone, so we're getting rid of this. I get 7x is 588. We're dividing both sides now by 7. So x is 84. Okay, so there were 84 adult tickets sold. And the way we're going to find our student is 115 minus that 84. And that's 31. So 84 adults, 31 students. Okay, try this one on your own. Got full fare and reduced fare. Okay, so the same thing, same trick, that we have the total number of passengers, but so the only way we can build it is like this. If we have X full fare passengers, the remainder must be 40 minus X. That's everybody else. So my dictionary is now built. Full fare was $32 per person. Reduced fare was 40 minus X. And if you add that up, you get the 1196. Okay, I'm distributing. So sending that 26 to both of those. Okay. So I'm combining my like terms. 32x, take away 26, I'd have 6 left over. So I want the factor puzzle alone, so I'm getting rid of the number. Get 156. Now divide away the 6 to get x alone. So X turns out to be 26. So there were 26 full fare. So the reduced fare would be this. So the reduced fare is 14. Okay, I think this is our last type here. So we're doing the same thing, but with stamps. So everything is exactly the same. So we've got 41-cent stamps, and we've got 2-cent stamps. Okay, now can we build? Okay, so we can build the 41-cent stamps off the 2-cent. So right here, it tells us that we can build the 41-cent stamp off the other. So it was 4 more than twice the number of 2-cent stamps. Okay, my dictionary is now ready. So we've got 2-cent stamps, and we've got 41 cents. So their value is in their name, but we have to have the value in order to get the total money. So this is now total amount of money. This is total amount of money. Adds up to the total amount she spent. Okay, so you could always clear the decimals. We've learned that trick earlier, but this one, I don't know, it might be worth considering, but I'm using my calculator, so I'm not having a lot of trouble with handling decimals. Okay, I distributed that through. Now I'm combining like terms. Okay, getting the factor puzzle alone, so I'm subtracting this away. Now I'm dividing both sides by that 0.84. Make it x is 8. Okay, so I've got 8 for my stamps. And now up here, I'm going to do it down here. 4 plus 2 times 8 is my 41-cent stamps. So order of operations, multiply first. Okay, 20 41-cent stamps and 8 2-cent stamps. Hold on, let me just see if, yeah, last topic. So this is a long video, sorry. So I've got 41-cent stamps, and I have 2-cent stamps. Okay, once again, we can build this off of the other one. So this is going to be my I don't know. So I can build 41 cent off the other one. 8 more than twice the 2-cent stamps. Okay, so 2-cent stamps obviously cost 2 cents. Now I'm distributing. Okay, now we need to tidy up. So putting my x's together, I get this. Now we want the factor puzzle alone, so we're getting rid of the 328. All right, I divided both sides by the 0.84 and got 12. So there were 12 2-cent stamps. So the 41 are 8 plus 2 times that 12. So I've got 8 plus 24, get 32. So 12 2-cent stamps, 32 41-cent stamps. All right, one more of these. And again, you can try this on your own if you want. I've got the 41-cent stamps, and I have 20-cent stamps this time. They're mixing it up on us. Okay. Yeah, once again we can build 41 stamps off the other one. So 20 is the I don't know. Now 41 stamps was 4 less than 3 times the number of 20-cent stamps. So it reads like this, but we know that we flip around less than to get this. Okay, my dictionary is ready. So I've got 0.41 times 3x minus 4 and 0.2. So just the value of the stamps adds up to the total value. That's amount of money, that's an amount of money, total money. So we got 3 times 0.41. So send him to both. Okay, we've got two groups of x's, so we're going to put those together. Okay, add that to both sides. Now, get the x alone. Alright, so x turned out to be 10. Now that was the 20-cent stamps, but we need the other one as well, which is 3 times 10 minus 4. So we've got 30 minus 4, which is 26. Okay, so that was a lot, but remember, we're just setting up our dictionary. We can define one of them off the other. Then you're multiplying the value of each of them together so that you have a total value plus a total value equals, or the overall total. So you got to make this money plus the total money equals the money on the other side. Okay, a little laborsome, but I hope you got through that.